Hey there, we're going to do the heat of reaction lab. It says lab 18, pages 44 through 47, 46, sorry, in your handout there. And we're going to be comparing 3 reactions, and we're going to use 2 of them to solve for the heat for the third one and see if they match up. So this is verifying here Hess's law. And we're looking at exothermic reactions here so that you can verify that Hess's law works. And knowing 2 equations, you can figure out a third one that you don't have to do in the lab. We're going to verify and do the third reaction in the lab so you can see that Hess's law works. But in reality, you can use any reactions that you already know and solve for a third one. Okay, so I'm on reaction number 1, and there's a bottle of sodium hydroxide here. And I'm going to click on here on the balance so you can record this mass. In reaction 1 on page 45, it says parameter reaction 1 mass of sodium hydroxide, so write that down. I'm going to zoom out. We already have the stir going in the calorimeter. We have a thermometer. We're going to be looking at this data here, and we're going to be graphing the data as well, so you can see what happens when I add sodium hydroxide solid into the water that's in the calorimeter. We're going to see what happens to the temperature. Okay, so let me make sure I have everything ready to go. I have a lab book open. I'm going to get a new page. Let me get to here, and let me move this down so we can see what's going on. Alright, so we're going to make sure the stir is on, so we see it moving there, so that's good. We always want to have the stir going in the calorimeter, and we want to have a baseline temperature of the water in here before we start, so we want to make sure that it's steady, which it looks like it's steady. There's 200 mils of water in here. And we're going to, we've allowed this to go for a long time because I've been talking, so we've allowed a baseline temperature in here. We know the amount, the grams of sodium hydroxide we're going to add to the water. And we're going to put it in the sodium hydroxide in the water. And we're going to see what happens. So right away you see there's an exothermic reaction of the dissociation of the sodium hydroxide in the water. So the NaOH solid is changing into Na plus aqueous plus hydroxide OH minus aqueous, and you're getting a temperature change. So anytime you have a chemical reaction, this is dissociation, you're going to have a temperature change or energy change of some sort. So I'm going to accelerate the time. So I wish we could do that in real life, but we can do it in this lab. We're going to accelerate the time and make this graph happen faster. And we're going to find the maximum temperature in the data. We're going to take the maximum temperature, the final temperature, minus the beginning temperature, and that's our delta T. Okay? So I'm going to save this. Let me make sure I do this in the right order. I'm going to save this. And now we have the first one done for us. And I'm going to label this reaction 1. And this was solid NaOH dissociation. Okay, so that was our first one. Now we are going to do reaction 2. So I'm going to click, I'm going to stop this, I'm going to clear this, and we're going to clear the lab bench. I'm going to go back to normal time. We're going to go to the stockroom. I'm on reaction 2, number 1. I click on the clipboard and get experiment number 5. So we're going to have aqueous hydrochloric acid, which is already dissociated, and solid sodium hydroxide. We're going to put those together and see what happens. So this is reaction 2. Return to the lab. There's sodium hydroxide here. There's approximately 4 grams. Let's write down how much that is. Write that for reaction 2. That's the grams of sodium hydroxide solid that we have. The calorimeter already has the 100 mils of water in it, because we want a final volume of 200. So there's 100 of water here and 100 mils of the acid here. The stir is on, that's good. And we're going to click save for our thermometer so we get the data. And we're going to let us have a baseline for a little while, make sure that that water is what that temperature is for our water in the calorimeter. Then I'm going to be on step number 3. We're going to add the hydrochloric acid, and we're going to put it into the calorimeter, and then we're going to make sure the temperature is at the baseline still, and there shouldn't be any temperature change because the calorimeter water and the hydrochloric acid were allowed to equilibrate at room temperature, and we have about 25 degrees, and we're not changing. That's good. Then we're going to take the solid sodium hydroxide and put it into the calorimeter and see what happens to the temperature. Okay, so here we go. So right away we have chemistry going on and we see a temperature change. I'm going to wait a while and then I'll accelerate the time so we make sure that we get our maximum temperature. Remember, delta T is going to be final temperature, the highest temperature minus the beginning temperature. So final minus initial. That's how you get delta T, always, always, always. So we're getting to the top there. Let's accelerate, make sure that we have all the data and we've gotten the highest temperature possible. So I think we're good. And then I'm going to hit the save button, and I'm going to give this data a name, and I'm going to call it, we had NaOH solid plus HCl aqueous, and that's the data for that. Okay, now I'm going to go to reaction 3. I'm going to stop this. Move this over here. I'll clear this out. Stop accelerating. We're going to clean up. Now we're going to go to the stockroom. I'm on reaction 3, step 1. I'm going to go to experiment number 4. This is aqueous hydrochloric acid. So dissociated in aqueous hydrochloric acid, and sodium hydroxide dissociated in water as well. So 2 solutions that are already prepared, and we're going to put them together and see what happens. So we have our sodium hydroxide and we have our hydrochloric acid, and we're going to put them together in the calorimeter. We have calorimeter spinning. We don't have any liquid water in here because these are they're already in water, so when we're done they're going to equal the 200 milliliters total. And so always we're having the same amount of water in here. The calorimeter is ready to roll, and we're going to put, we're going to hit save so we'll get our data. We're going to put in the first one, and we're going to make sure that it stays at the baseline temperature, which is 25. Then we're going to add the second, and now we're going to see the chemical reaction going on. And that neutralization reaction has an energy associated with it. And so all chemical reactions have some kind of energy associated with it. So we're seeing this exothermic as well. And we're going to accelerate the time so we can speed up time and get to the maximum temperature possible. And then it looks like we're at the max, and we're going to hit save. We're going to get our data. We're going to call this HCl aqueous plus NaOH aqueous for that data. Alright, so now I'm going to give you your data if you didn't write down the max there. And then you're going to be able to do all of this data interpretation on the last page, page 46. So let's go through the data and I'll put it up for you so that you can see what we got here. So first one was the solid NaOH dissociation. It's on the next page. So I'm going to pause this for a sec, get the data for you. I'll do them in order, reaction 1, reaction 2, reaction 3, so that you can have the data. Okay, here's the data for adding the solid sodium hydroxide into the calorimeter, into the water. So this is dissociation of sodium hydroxide in water, and here's the data. So make sure you start at the final, get your highest temperature off this data. Whatever you think is the biggest number there. And then subtract it from our initial temperature, and that's going to be your delta T. Okay, so this is the data for dissociation of sodium hydroxide in water. So it's called the heat of solution. Okay, I'm going to stop there. That's the first set of data for heat of solution, solid sodium hydroxide in water. Okay, here is the data for reaction 2, which is the solid sodium hydroxide reacting with the aqueous hydrochloric acid. And so we started at 25, remember, and find your maximum temperature to get your delta F. Your final temperature, delta TF, and you're going to do the change in temperature final minus the initial. So take the highest, the ending temperature minus the beginning temperature. That's how we do delta T. And use that for reaction 2 data. Okay, and then I'm going to stop, and then I'm going to get you the reaction 3 data, and then you can have all your data. So I'm going to pause for a sec. Okay, here's reaction 3, where we had the aqueous sodium hydroxide and the aqueous hydrochloric acid, and we mix them together. And here's your beginning temperature, and let's run through to find the highest temperature for your final. And then do your delta T, change in temperature, final, highest temperature minus initial, which was your baseline, 25 degrees. Okay, so that's your data. Now you're ready to do all the analysis of this lab. Good luck, and I'll talk to you soon. Bye-bye.